Okay, so let's first talk about the new things, because this is applicable to everyone, whether you've been in my classes before or not. So if you haven't noticed already, we're using Google Classroom this year. Google Classroom is not, for those of you who were in my class last year, replacing the notebook, but it is improving on the notebook. We're using Google Classroom primarily as, I don't know what these little tiny children have done to this board, but it's like horrific. Hopefully it functions properly. See what happens. Okay, so Google Classroom is going to give us an extra layer of accountability, which I think is going to be useful for some of us, because we have notes and homework. All that's the same as last year and whatever else. And don't worry, those of you who are like, I wasn't here last year. I will explain in more detail in a minute. But notes and homework is the same as last year. Pretty much the same grading of it as last year, although there's an extra layer to the grading this year. Yeah, let's talk about that first, and then we'll talk about Google Classroom. So, notes, you watch the video, you take the notes, right? You take good notes that are neat and organized, that include all the information. If I write it down on the screen, if I took my time to write it down on the screen and make it for you, you better put it in your notes. There are often things that I say out loud that wouldn't be a bad idea to put in your notes. If I say something like, this is important, maybe write that down, right? Keep your notes organized and keep your notes in your notebook. Your notebook should have all your little tab dividers. Each tab is a new chapter, right? What I would do if you bought tabs like these is I would put your unit 0 in front and then 1 and 2 so the numbers match, but you can do whatever you want to do. If you have other tabs, you can do that however you want, but each tab is a new chapter. Okay, we're in chapter, no, there's no chapter 0, just kidding. There's no chapters. This is the only class where we skip the review chapter. So chapter 1, beginning in chapter 1. You take the notes and you take the homework, and it's not a tab for homework, a tab for notes, a tab for whatever else. A tab for chapters. That makes sense? If you're like not an organized person and you're gonna forget by the time you have to turn in your notebook for a grade, I would write it down somewhere. Because you're going to get a notebook grade that is separate from your notes grade and your homework grade this year. Your notebook grade is a responsibility grade. It's a do the work grade. It's a jump through the hoop grade. Full transparency. It's not a math grade. It has nothing to do with math. Nothing. Well, unless you're a goofy person and think math is about organizing stuff, it's not, but that's what some people might think. But that's what that is. So each tab has a chapter in it. In the tab you need notes, and then you need homework, and you need quizzes, and then the test I'll give back to you. Probably in your notebook, probably. Because when you take a test, you'll turn in your notebook and the test after you take it in person. Make sense so far? Easy peasy? Okay, so the homework, you need to do the homework. You might have noticed in the Google Classroom, and I'll get to more specifics about Google Classroom here in a second. All right, let me see if this is our student that isn't here yet. Nope, incoming spam. Go away. What was I saying? Oh, the homework. You need to do your homework. You might have noticed that the due date in Google Classroom is the day before class. That's like that for a reason. That is always going to be true. I don't want you doing your homework at 7 o'clock in the morning before you come to class. I can pick on somebody specific, but they're not in this class. They're in a different class. Everybody in that class would know who I was talking about. But, it's fine. Gracias. Thank you. Let's do that before it dies. Sorry, Jacob. I'm not trying to get all up in your Kool-Aid. Beautiful. Look at that. AC power. For those of you who have been in my class before, this could be really great for Miss Gina Eloise, because she has to be remote every time. The recording part, now as far as like you sitting, I think we have enough space that I may connect you to that feed, and I may not. Your live feed may just be the normal crappiness, or maybe whatever. But the recording we're doing this year is going to have good video and audio. And so if you do have to miss, I'm totally on another other page. I'll come back to notes and homework. But while I'm thinking about it, if you do have to miss, you need to do the work, and you need to watch the video recording of class. Other than a couple of, actually really I think only one, other than a couple of exceptions for specific reasons, we're not going to do any virtual class, whatever, unless like I'm dead or the snow is 10 feet deep or whatever else, and we're all at home, and then I'll be sitting in my basement and teaching you from there. But other than that, like you're not going to join live, whatever else, because there's no point in it, because 98.5% of the time the student just sits there with their camera off and probably falls asleep. So there's no point in that. You generally participate more than most, which is not saying a lot because the bar is really low, but you know, in a virtual space. So if you miss, there'll be a recording in good quality with good quality video and good quality audio and all that kind of stuff. So you'll actually be able to see what's happening without a giant glare in the middle of the whiteboard. Hopefully the whiteboard is going to work. A little terrifying. Okay, back to our thing. So homework. Homework is a little bit more confusing on how to do it, because those of you who've had my class before kind of know the flow of things a little bit, but you watch the lecture video, so you've not seen me in person, and then you do homework on that topic. And so you might be confused on it. You might have questions on it. You might get stuck. There might be one or two problems you're like, I don't know how to start this problem. Okay? So this is what I expect when you turn in that notework, that homework. I want you to turn in your homework on time, even if there's 2 or 3 problems that you're confused on. And this is what I expect, and this is what I am grading. Now today, this first homework is an exception. This first homework, there's no late, there's no what if it's ugly and like horrific and whatever else, that's fine. This first one, just turn something in and you'll get a 100 on it. Yay. If it's there is no penalties for almost anything on this first one, because we're learning and you hadn't seen me yet and all the things. All right, so don't worry about that. So if you haven't turned in your homework yet, go home, turn in your homework. If it's half finished, turn in it anyway. Turn in something. It doesn't matter. No big deal. This first one, we're not worried about it. This first one is just, oh yeah, I understand how to use Google Classroom. Here's the thing, right? So on your homework, I am looking for whether you attempted every problem. That might be you wrote the thing down and made like half note of, I don't know where to start or whatever. That's fine. That's fine on a problem. That's totally fine. That's why we meet in class. That's why my face is here and your face is here. That's really kind of the point of doing the homework, is to be able to take a look at, okay, what do I get right now? Where am I struggling? And where am I working through these things? And then we come to class and then we fix all the things that are broken. And then you get to take a little quiz and see if we really fixed it. If we didn't, then we fixed it some more. And hopefully by the time we fixed it a lot of times, you get to the test and you can do the thing, right? So that's our goal there. So I am actually grading your homework. Now I'm not grading the answers. I am grading, does this problem that was assigned have work in it that looks like it basically kind of sort of maybe might match the thing. They might be off in left field, they might be wrong, they might be confused, whatever else, and if that happens, I'll get to make a note of it, and even before you have questions, I may know some things that we need to look at, whatever else. Or there might be one problem that everybody wrote, I don't know on it, or whatever. It's like, okay, that's clearly a thing. So that's the expectation with that. Homework is still basically a completion grade. Did you do it? Did you do it on time? I'm taking 10 points off if you turned in late. And your punishment for not doing your work is doing your work. So you get 10 points off, and then you still need to go do the work. So don't get behind. It's the more, as some of you will attest, the more you get behind, the more frustrating it is to get caught back up. This is just the truth. So don't get behind. If you do get behind, get caught up ASAP. If you need help and you're like, I'm struggling, then we'll set up some office hours or do some things or whatever else and get you caught up. One of the biggest things you learn in high school, and especially one of the advantages you guys have in being in a class, is you get to do things like this. But one of the advantages is you learning how to advocate for yourself, and being able to go talk to your boss or your superior and be like, okay, this task I don't get it. I need to understand, or I need more resources, or I need whatever else. This is a life skill that's exceptionally useful to you in your life. You may be like, I'm an introvert. I am so scared of people. You'll be okay. We're going to practice the skill, baby steps. If you need to communicate with me only through email, that's fine. If you need to be like, I'm struggling with whatever, that's fine. Not a problem. If you need to yell at me in class and be like, I don't get it, that's fine. Just don't cuss me out in front of other people. If you need to cuss me out in private, well, whatever. No skin off anybody's nose. But, just don't cuss me out in front of class. Easy money, right? So, as far as the picture uploaded to Google Classroom, it doesn't have to be perfect. It needs to be good enough that I can basically sort of kind of see what's going on. Like if it's so blurry or so whited out that I can't see, oh yeah, they attempted this problem or whatever else, then I can't. So it doesn't have to be amazing. So if you have like El Cheapo Android phone, and it'll make a kind of blurry picture where I can still basically see the math, that's good enough. It's fine. I don't care. Whatever else. I am not taking any turning in work any other ways this year. Borrow your mommy's phone, do something, figure it out. Find a way to snap a picture, even if it's like not the best. It just has to be kind of vaguely good enough. Does that make sense? If you take your picture and you're doing this, I get this too, and you're holding your thing and you're holding it like this, and you take the picture and then the sun is shining on it and you can't see this half of the thing. Put the thing down on a table and retake the picture. Just, again, that's not like, it doesn't need to be great, just good enough. Like if you're looking at your picture and you can't figure out anything on the page, retake the picture. It's really not that big a deal. It's not meant to be a terrible thing. So a question that some of you have had in my class before might be asking is, are we doing grade sheets? Right now, the current plan is to just use Google Classroom as our grade sheets and whatever else. If it looks like we need to, for whatever reason, bring the grade sheets back, we will do that. But for now, we're going to just do one thing and see how that goes. Any questions about class? Hey, how are you? Good. Oh, oops. That's all right. Welcome, welcome, welcome. Here's a book.
Page 21, 2 through 23 is not.
Okay. Any questions about just class in general? We'll get into the math here in a second.
Our test and quiz is going to be the same setup?
Mm-hmm. Pretty much, yeah. Yes, quizzes and tests will be the same stuff. It's worth, I should note this now. I often wait till we take our first test to kind of talk about this, but it's worth noting now because sometimes it seems like people don't pay attention or don't listen or don't remember or whatever else. And this is kind of a big deal for some of you that are on your first test are going to make a 65 or whatever. I mean, because that happens sometimes. That happens. That's when you do things and you have a new teacher, new subject, new whatever. Sometimes you don't really know how to do it well, right? And so you're liable to make a bad grade on a test, right? You're liable to make a 80 and you're like, that's not good enough for me, whatever else, because that's how you roll. That's whatever, that's fine. Okay, so you can correct tests. The way test corrections work for me, I've done it this way for quite a few years now, and I like what it goes. The point, you need to understand that the point of correcting a test is for you to have one more chance to engage with that material and learn the stuff that you didn't know that caused you to fail the test. That's the point. That's why I allow corrections. It's not just for your grade. I don't care about your grade. I really don't. It doesn't matter. You know, and you should only barely matter. And the only reason you should care about your grade is because of scholarship money. Other than that, nobody cares. Nobody cares if you made a C in high school. You're going to go get a job and nobody's going to care. So grades do not define you. That's very important to understand. That's very, very important. And being able to learn that material and get the things, that's going to help you in the next thing. So we're re-engaging with the material. So when you do test corrections, and I will explain this again when we take our first test. As when you do test corrections, you have to do them on a separate piece of paper. You have to correct everything you missed, even if it's just a little sign mistake. Every problem you missed, you correct them all. Okay? When you turn in corrections, they have to be complete. They have to be correct. They have to be completely correct. When I give you your corrections back, you will have one of two grades on them. It will either say 100 on the top of that, the corrections, or it'll say fix. If it says 100, you're done. We're done with this exchange. You corrected the things. We've got it back. And I grade corrections harder than I grade tests because you have time to actually do it and ask questions and do the things. So it has to be perfect. It has to be perfect, right? So if it says fix, then what do you think you do? You fix it, and then you give it back. And then we keep on doing this until it says 100 on it. Usually, once we've done one of those type of exchanges, everything after that, it's either 100 or just one fix, and then we move on with our life. Make sense? Any other questions about class? Okay, so let's look at the math. So you should have taken notes on 1.1 and 1.2. You also should have attempted the homework on 1.1 and 1.2. So normally, I won't go through this huge spiel of these are the things we're doing in class. Normally, the first thing we'll do in class is we'll go through and I'll read the answers to you. And you can see whether you understood it as well as you thought you did or not. Okay? So you need to pull out your homework for 1-1. What problems did we do? Somebody know before I? 2 through 20 evens. Okay, so I'm going to give you the answers. We'll do 1-1 and then we'll go through and look at and see if anybody has any questions on this lesson. And then we'll do 1-2.
Pictures you sent me, I could only see like some of the questions. I couldn't see all of them.
Okay. Yeah, again, we're not worried about this first assignment. So you may want to at least look at those questions, but I mean you can submit what you have for this first assignment, and I'm not worried about it. But you may want to at least look at them and make sure you understand them or whatever. Okay, so number 2. So there's different possibilities. You could have put L, little cursive L. It does so. Before we go through this, I should I do this kind of in the notes videos, but I should make these statements now as well. Geometry is a different class, different type of math class than you've ever taken, ever. Especially my geometry class, because I teach a real geometry class. So I don't understand why they quit doing it in public school. Took out a lot of the proofs and whatever else, like the whole point of it. Because in case you didn't know, the reason why you have to learn how to factor polynomials in high school has nothing to do with factoring polynomials. The reason why we learn proofs in geometry has nothing to do with the proofs. It has everything to do with learning how to think that way, stretching that part of your brain muscle, right? That's what those things are for. You don't go into the gym and bench press That's in order to, on the street, somebody goes and throws a bench in front of you and you have to bench press. You go to get those muscles stronger, right? Same thing with these things. So geometry is a math class, but it's not, at some moments, it's not going to feel like a math class like you know it to be a math class. In fact, geometry is actually closest to a real math class, like a real math major math class that some of you will ever see. Probably most of you, right? So geometry is all about logic and all about learning how to reason and doing all of those things. Some real classical looking stuff. Okay? So you're going to have a lot of like writing in geometry class, a lot of memorizing. Geometry is kind of the biology of math class. You know, in biology you have to just memorize a bunch of stuff. My wife joked, she teaches biology, so she gets to make this joke. She joked that biology is just stamp collecting. We're just, okay, this is this, and this is this, and this is this. Geometry's got a lot of vocabulary, a lot of stuff. If you are not a flashcard person, you might want to start with geometry because there's going to be a lot of stuff to rememberize. Lots and lots of stuff. So what I was saying, and that caused me to go on this tangent, is the way you write your letters matter because of convention, right? So a lowercase cursive L in this case is saying this is a line. So lowercase cursive letters are a line, right? Uppercase letters, what are those? What did you learn from your video? What are uppercase letters? Uppercase non-cursive letters. What are those? Points, yeah, that's great. Okay, so let's continue on. So it does matter. So a lot of you, you know, and in Algebra 1 and pre-algebra, I may make a note of it, but I'm not necessarily going to count off if the problem has a lowercase a and a kid writes uppercase A and whatever else in this equation or whatever. And in geometry, it matters. So it does matter. If you're used to doing that in your math and whatever else, don't do that. Write the one that you're supposed to write. Okay? Slow down enough that it's neat enough. Number 4 is line. Number 6 is a picture. I'll put it up on the screen here in a second. And number 8 is 5. Number 10 is no, because A, H, and J lie in plane ABF, but point D is not on that plane. Number 12A is points. Number 12B is no, because there is not a straight line through all 3 points, so they're not collinear. 12C is yes, by definition. 3 collinear points are coplanar. Number 14 is 2. There you go, we did it. Number 16 is C. Number 18 is no, because point F lies in plane R, while points G and P lie in plane Q, and M lies between R and Q. If you didn't, again, this first homework assignment, we're grading it kind of loosely, right? But if you did not, on some of these, write your justifications, your reasonings, you should start getting in the habit of doing that, because when we get to the next chapter and we start doing proofs, that's what it's all about, is writing this thing is true because of this things. Learn to abbreviate clearly and save you some time and trouble.
Some of the problems do say explain.
So they require an explanation. That's true. There's number 6, or a possibility. It says sample answer. I didn't read what the problem was. Yeah, there's number 6. We can look at any ones that we need to. Number 20 would be line CE, and it's worth noting that the right way to write that in that problem is CE with a line over it. So, what questions do we have on that lesson?
12.
Okay. Seems like the whiteboard is going to work. Yay. Number 12, Ursa Minor, the Little Dipper, is a constellation made up of 7 stars in the northern sky, including the star Polaris. What geometric figures modeled by the stars? So when you're looking at that little picture, let me put the picture up on the screen since I still have the ability to do that. Put the TV on. So there's our thing. So it's asking what for part A, what are the stars? What geometric thing are the stars? Points, right? Easy peasy. Are star 1, star 2, and star 3 collinear on the constellation map? Explain. Okay? So, 1, 2, and 3. What does collinear mean? That's really the point of the question, right? What does that word mean? On the same line. So are 1, 2, and 3 on the same line? No, because the 3 curves over. 1 and 2 are collinear. 2 and 3 are collinear. Any 2 points are collinear. 2 points by himself, but 3 points not always, right? Okay. Are Polaris, star 2, and star 6 coplanar on the map? What does coplanar mean? On the same plane. So that's an interesting question because we could argue that both ways, right? Because in the universe, stars, whatever it says, Polaris 2 and 6 are not coplanar. Well, actually, no, they would be. Yeah. Yeah, they would be because that's 3. How many points does it take to make a plane? 3. So if you have 3 points, they're coplanar, period. So yeah, you can't argue it. I lied. Just kidding. If we had a fourth point, they wouldn't necessarily be coplanar, right? But any 3 points are always going to be coplanar. And definitely if we look at the picture, and when we're talking about just the picture, they're all 3 on that same flat plane, right? And so they are coplanar.
The flat plane being just the
The
background?
page. Yeah, yeah.
Oh, okay.
Yeah. But importantly there on that point that any 3 points are always going to be coplanar because it takes 3 points to make a plane. Now they're not going to be coplanar with some other point necessarily, right? Because if we had 3 points on this plane, 1, 2, 3 points, then we could have a fourth point over here and it is coplanar with those 3, but if I have a point out over here, that's not coplanar with these 3, right? But it would make it, and this is, you got to be able to twist your brain around, right? If I had another point over here, it would be coplanar with like just these 2. It would just be a plane that's coming out this way, right? It would be just a different plane. Does that make sense? Any questions on that? Any other questions on this lesson?
Math existing outside of 2D spaces? Ugh.
What?
I mean, I guess it is still 2D, but
Yeah, a plane is 2D, yes.
it is still 2D, but it's different.
But it's different. There's multiple 2Ds, which is how 3D is made, with multiple 2Ds.
We should all bring Play-Doh to class.
Let's not and say we didn't. Any other questions on this lesson?
Does it matter which letter is first? Like on number 20, I had wrote down line EC. Doesn't matter if it's CE or EC.
So sometimes it matters, and in this case it doesn't. For a line, and then let me give you a little bit again. Let me give you a little bit more words because it's a good question. It's a really good question. So if I have line EC, right? So if it's line EC, it doesn't matter because the arrows are both going both ways, right? But if it was, say, we haven't necessarily talked about this yet, but you're gonna soon learn what this means. Anybody have a guess what that means right there? That's array. We talked about this already. Did I give this to you in a video, or y'all are just brilliant? Okay, great. So ray EC, that does matter, right? Because then that would be this ray, the one going this way, not this ray. So in this case, it doesn't matter because it's a line, but sometimes it does, and order definitely is something that's going to matter on some things. So keeping that in mind and thinking about that. But in this problem, it definitely doesn't because it's talking about a line. Great question. Any other questions on this lesson? Yes, sir.
You have 3 points on one line, are they coplanar?
If there are 3 points on one line, yes, they're coplanar. There, on any given line, there are an infinite number of collinear points, right? Because a line is made up of infinite points going forever and ever.
You could put like a ton of dots and then connect them all and call it a plane? No.
No.
Okay.
So all of these, which is why they're the undefined terms, right? These are the foundational things. These are because these are so conceptual that they don't have really formal definitions, right? Point, line, and plane are the 3 undefined terms of geometry. They're the basest of levels, right? They're an idea. A point is a point, right? And we can't really define it much more than that. A point is just a single dot, but it isn't really a dot because a dot would take up space, right? It's just a single point, right? A line is a line. Like, so there's a line right there, a line segment, really, at where the wall and things meet. So lines are where 2 planes meet, really, right? That's what lines are. Points are where 2 lines meet, or infinite lines meet, or whatever else, right? A plane is just flat surface stretching to infinity. So no, you can't just randomly connect dots and call it a plane, because a plane is something that goes on forever and ever. Now I can randomly put dots on here on this board, and for the sake of philosophy, this being flat, those would all be on a plane, right?
Well, I wasn't talking about like that or something like that. I was just talking about like a bunch of dots.
A circle of dots.
No. Like just a bunch of dots that make a thing that's not like crossing each other.
They don't have to cross each other. Well, points can't cross each other. Lines do. You're good.
I'm ahead of myself on my thing too because I'm doing it here in class because I didn't know it. So I was having a question on that.
I see.
I would have sent you the problem. What you could have asked.
You could have asked me. I sent people pictures.
There are people that could have.
It's all right. It's okay. There's much grace always, and even more on this first day. Okay. So, any other questions on this lesson? Okay. Let's look at the other lesson, and then we'll see what time it is, and we might even take our first quiz. Yay. I saw that face. You can't hide from me. All right, what problems did we do on this one?
2 through 20.
2 through 20. Look at that consistency. Oh my goodness! Second one. Okay. Number 2 on page 20. 2.4 centimeters. You didn't put centimeters, part wrong, because word problems have units. And in geometry, every problem is a word problem almost. But not every problem has units, so I don't know. We're breaking down on our logic. We'll talk about logic in the next chapter. Number 4, x equals 3 and the measure of BC equals 3. A note, I think I talk about this in the video. I do at some point for sure. Textbooks use different conventions sometimes for how they label stuff. In fact, I had a friend that was a mechanical engineer that he had one class in college where the professor made up his own notation and had it all in the back of the book. So you had to go and memorize his new notation to do the thing. So different books use different notations for things. So this is going to become more and more important, especially starting in the next chapter. So pictures are congruent, numbers are equal, right? And so if I have line segment AB, right? That's line segment AB, right? That's talking about the picture. If I'm talking about how big it is, then I put a little measure, put a little M for measure. Your textbook uses bold letters to be the M. I can't write in bold letters, at least not quickly. So That's so when it's got bold, like the BC there, it's talking about the measure of BC. Well, and you can't even see it that way. But for in the future, I'll say some of those things again, but it's good to say some things early and often so we get them in our head. Number 6 is 9. Number 8 is the square root of 106, or about 10.3 units. Number 10 is B and C, and then A and C. Number 12 is 5.3 inches. Number 14 is 2.1 millimeters. 16 is 4.4 millimeters. Excuse me. 18, C is 18, and the measure of YZ is 12. Number 20, A equals 4, and the measure of YZ equals 20. 22, N is 4 1/3. The measure of YZ is 1 2/3. 24 is 5, 26 is 9, and 28 is 12. What questions on that lesson do we have? Number?
4, 18, and 22 are all the same type of problem. I'm not sure how to do them.
Okay, well, you're sharing a feeling about 4 at least. So let's look at it.
Well, yeah,
Those 3. Did you read the bold text?
Yeah.
And we're confused about the bold? Okay,
I
good.
don't know the equation about when y is between X and Z.
There's not an equation. It's describing a picture. Now, this is first advice. Yes, ladies? Yes.
Or what's it called? On 12, what was the answer for that one?
5.3 inches.
Thank you.
You're welcome. Yes, ma'am.
Can we go to that?
Of course. Okay, so here's your first piece of advice for geometry. This is actually first piece of advice for math and science, both. Like every math and science class, just period. Especially when you go take physics later. This is great advice for physics. If a problem describes a picture and the textbook, test, quiz, whatever, does not give you a picture, draw a picture. This is your first piece of advice, right? So that's what's going on in this problem. So it says find the value of x and BC if B is between C and D. So because of the convention we just talked about just a minute ago, B, C, and D are all whats? They're all what? They're all collinear. And that's actually, we have to assume that or else this problem's impossible, right? But they're also points. I don't know who said it, but yes. They're all points, right? So we've got 3 points on a line, right? We've got, it must be just this. Oh, sad.
Mr. Fulkerson, you remember that one time?
Yes, I do remember that one time when you accidentally hit me in the face with a marker. I do remember that happening.
It was definitely accidental.
Good
I
times.
don't know what you're talking about.
Yep, that's why I stapled your book.
I kind of forgot about that.
You did? All right, let's try again. Or maybe just that spot on the whiteboard. That'd be depressing. All right. Okay, so we've got a line segment, and it says that B is in between C and D.
So it says in between. Does that mean it's halfway?
No, that's a great question, actually, right? So that's actually a really good question, and because we're going to deal with midpoints and bisectors and all that kind of stuff later, and this is really important. That's another thing that we need to understand, especially in geometry. If something isn't stated, it's not true. We got to keep that in our head, and that's really important. That's really, really important. If something doesn't say it, if something looks 90 degrees, but it doesn't say it's 90 degrees, it isn't 90 degrees until you prove it's 90 degrees. Right? That's very important to understand. I saw a meme one time where these guys were in the car are being like, math says prove that this is a rectangle or whatever, and it's clearly a rectangle, right? But yeah, you got to prove it. And you got to go through multiple steps to prove it, and you got to use theorems to prove it, and all the things. You're gonna love it. I love teaching proofs. Geometry is one of my favorite things to teach. I love teaching geometry, which is I'd say that about every class after Algebra 1. Algebra 1's fine, but like every class after that is my favorite. But geometry is fun. Geometry holds a special place in my heart because it's so much torture for students. It's so great. I love it. It's great. Great. Proofs are fun. And this jokes aside, it is really fun because you're in chapter 2, you're gonna be like, oh my gosh, I hate proofs. I don't know how to do them. I'm so confused. This is horrible. That's almost certainly what's gonna happen. By the time we get to like chapter 5 or 6, you're gonna probably be able to kind of write a proof, at least somewhat. And it's gonna be impressive. And it's gonna be really cool. Yes? Oh yeah, you got to die a few times first. That's muy importante, right? Okay, there's the picture. So your question, no, it's not in the middle. All we know is it's in between them, right? So then in question 4, it says that the measure of CB is 4x minus 9. It says that the measure of BD, excuse me, 3x plus 5. Right. Yep. That makes sense. And then it says CD, so the big one is 17. So how would we solve it?
We would add 4x minus 9 and 3x plus 5 equals 17.
So in geometry, there are essentially 2 types of problems, 2 like categories of problems. I think I say this in the video too, but y'all don't always listen. So sometimes things have to be said lots and lots of times. There's problems like this where you're given some picture and you have to use the theorems, postulates, whatever else to be able to take that information, turn it into an equation, and algebra it out and get an answer, right? So, and usually the hardest part, if your algebra is even like pretty much fine, and it's going to get more and more fine as we're going to do very similar equations over and over and over again, right? So, excuse me. Usually the hardest part of those problems is writing the equation. So once you can get an equation, then it's just easy peasy, right? So this is our equation, right? So how do we solve this? If you're like thinking in your head, my algebra is not really more or less fine, make sure that you ask a question if you have it in the algebra parts and whatever else. Probably somebody else is thinking the same thing. If you're like, how did you do that? Why did you do that? What is going on? Ask the question. That's why we're here. That's why we're in person, right? That's the advantage. I could bundle this up, and eventually probably will, and bundle all of this up and give it to parents and let the kid go home just like a Matthew C. or a teaching textbooks or whatever else and do the thing, right? And they could do the thing on their own and whatever else. That is a thing that could happen. But the advantage of taking this class like this is me. I'm not saying I'm all that great, but I've got some experience helping people. So take advantage of the fact that you have me.
So why do we have, how do we know that we're using a plus, addition in the equation?
Well, when you go watch the notes video. Oh, good. So what kind of problem is this? What postulate are we using in this problem? What postulate deals with this kind of shape?
Postulate?
Yeah.
I don't know if there's a fancy name for it, but it's just a big addition problem.
There is a fancy name for it, and it is segment addition. You know how we know it's segment addition? What is this shape? This CD thing? It's a line segment. So we've got segments addition. 2 little segments adds up to make a big segment. In the next chapter, we're going to take and use this to prove something else, because this plus this equals this. This other thing is true. Right? For now, we're just doing some algebra with it, right? So these 2 little things added together equal the big thing. And that's what segment addition postulate says. So that's how we know. Does that answer your question? Good enough? Good. Okay, so any other questions about how we made the equation? Okay, so So let's solve the equation. I think we're done with that, yeah? Okay. How do we solve that?
Combine like terms,
Yep, where are they?
4x and 3x.
So before I combine like terms, I put these in parentheses because we're adding this whole thing plus this whole thing. However, with a plus outside of a parentheses, do the parentheses matter? No. If this was minus or a number, right, it would matter, yeah? But since it's plus, we can go ahead and kill those parentheses.
Why would it matter if it was a minus?
Because if it was a minus, remember we'd have to distribute that minus over here. Yep. Okay, so yes, y'all were correct on where they are. We've got a 4x and 3x. Where else are there like terms?
-9 and 5.
-9 and 5. You're going to notice if y'all were in my Algebra 1 class, there are going to be some instances like this where we do two things in one step. Now, my recommendation still is and will always be, because it's a strong advice, no matter how good you are at math, because it makes you slow down just a titch, just a tiny titch. You can hold two things in one hand, whatever else. I required this once, 1 year, and that's it. I don't require it for anybody. If I was going back to teach middle school again, I would require it. I would make them do it, but I'm not going to make you do it. But I recommend doing your alternate steps in a different color. These little intermediate steps, because it makes things clear and makes things slow down. Now, this is also really important. Some of you never had me in class, and some of you, even if you've had me, still struggle in this space. On an algebra problem, we take a new line to do the new things, right? We don't smoosh it all into one thing or put it all over a page or whatever else or whatever dancing nonsense, right? We do a step, have an intermediate step, and then write another thing, yeah? So when I put a new line, you go to a new line. Paper's cheap and pretty much completely recycled these days. So don't worry, you're not killing the planet. Use the paper. Take a cue from Helen. Use as much paper as you need.
You might find a way to kill the planet through recycled paper.
Okay. What's 3x plus 4x?
What?
7x.
Love you.
What is -9 plus 5?
-4.
Now what do we do?
Add 4.
Add 4. Great. Do it to this side, got to do it to this side. Bring down the 7x equals. What's 17 plus 4? 21. Now what? Divide by 7. X equals, what's 21 divided by 7? 3. Any questions on this problem? Okay.
What about the BCAs?
Oh, yeah, we're not done with this problem. Gotta go back and finish reading. And find the measure of BC. So what do I do now?
Put back the x.
Put it over here. All right, because this is BC. That's great. Love it.
Yeah. I'm working to kill as many trees, but
What do we do now?
Multiply the 4.
And then 12 minus 9 is 3. So, isn't what?
I thought it was negative.
Oh, no. You should get in the habit of writing the measure of the thing equals that. Numbers are equal. So if you put an equals, it's a measure, yeah? This is going to become more and more important. The more you get in these habits early and often, the better. Right? This is if you want, the annoying thing about geometry is it's fiddly. There's a lot of little things. And so the more you get in those good habits and build those good habits now, the better we're going to be, right? Or more Ruth. Ruth's mother had some questions about geometry. I can't answer that right now.
Could we do 26?
Yeah, really fastly we can do 26. We got 3 minutes. 26? Y'all, that's like a 7th grade problem.
Yeah, I got smarter.
What is going on with my whiteboard? I don't know. Okay, please. I saw that on a video the other day. I haven't tried it, but yeah, see what happens. All right, number 26. We got a number line. That's beautiful. That's just like how your work should look. No, don't. We just got 3 minutes. We got this. And K is at -4. And P is at 5. Process. And we're expected to find the measure of KP. How do we do that? Okay, so distance, we subtract the numbers, right? To find distance, we subtract the number. Or you can just sit there and count the number line, right? Is that what you were going to say? Yeah? Okay. Yeah, you can. So the algebraic way to do it would be to find the absolute value of them subtracted. It's absolute value because this is more like words for physics later. Distance is always positive. Distance is a scalar. It's not a vector. Distance is always positive. Displacement can be negative, but that's more like a physics thing for later. So throw that in your brain for later. What's -4 minus 5? -9. The absolute value of -9 is 9. So the measure of Kp equals 9.
So it was just easy as the answer. Alright.
Yeah, it was as easy as it looked. Yeah, there wasn't anything magic. All right, kids, we're about done with class. We replaced quizzes today with talking about the class. I'm sure y'all are very sad about it. Don't worry, we'll have quizzes later. It'll be fine. So.